Alright, let's look at the homework 9.3, problem number 8. This is a copy problem. Alright, so differential equation is given, and the coffee is initially at, let's see, 93 degrees Celsius. So we have, we can just add the initial value condition, y of 0 is equal to 93. Alright. So we just need to solve this initial value problem. Alright, so let's do that. Alright, since this is a separable equation, I'm going to put all the expression in terms of y on the left and everything else on the right. Alright, so first thing I would do is from there, I'm going to divide the equation through by quantity y minus 23. Alright, so we would get the 1 over y minus 23. Alright, dy over dt is equal to negative 1 over 50, and that's it. Alright. Then we can integrate both sides with respect to t. Right, so we're gonna have it put the integral sign and the dt there. Right, then we can cancel dt on top and dt on the bottom. Right, so antiderivative of 1 over y minus negative 3 would be natural log of y minus 23, right? Then antiderivative of negative 1 over 50 with respect to t would be negative t over 50, right? Plus some constant, I'm going to call it the C1, all right? Then, to solve for y, we're going to raise e to both sides. Right, then you have e to the natural log of absolute value of y minus 23. Right, then we can cancel e and natural log because they are inverses of each other. All right, then you have e to the negative t over 50 plus c1. Right. Then we can split it as I'm going to do e to the c1 first. I'm going to write the e to the c1. Right, then you have a times e to the negative t over 50. All right, then we can take out the square root, not the square root, the absolute value sign by putting a plus or minus, because it could be a negative version of that. So you have y minus 23 is either positive or negative e to the c1 and times e to the negative t over 30. All right, so since plus or minus e to the c1 is just going to be a number anyway, so there's no need to put such a complicated expression. So I'm going to call it just c. All right. So this is going to be c times e to the negative t over 30. All right. Then since we're looking for y, so it's going to be y is going to be equal to, so add 23 to both sides. We get this is equal to 23 plus c times e to the negative t over 50. All right, did I put 50 here? That looks like 30. All right, 50. All right, so that's the best we can do just from the differential equation. Then we can use the initial value to find the value of c. All right, so we have y of 0 is equal to, so plug in 0, so you have a 23 plus c times e to the 0 is 1, so it's just going to be c. And we know that this is equal to 93. All right. Then we can just subtract 23 from both sides. So C is going to be 70. All right. So therefore, we have the complete function formula for y of t. So that's the temperature function. It's 23 plus 70 times e to the negative t over 50. All right. So let's type this guy in. All right. Open this up. All right, so we got, let's see, we're talking about y of t expression. All right, so it's going to be 23. And let's see, should I do y of, I'm going to just go ahead and type in 23 plus 70 e to the negative t over 50. All right. So let's submit for testing. All right, looks like it didn't like my answer, but maybe it's y equals. All right, so submit for testing. All right, it came back, and I think that was the problem. So y equals 23 plus 70 e to the negative t over 50 is the expression for the temperature of the coffee after t minutes. All right. That's it. I hope that this was clear.